Hey everyone, in this video we are going to discuss occlusion culling. So to begin, let's talk about what occlusion culling is. Essentially, let me just go ahead and start playing this very basic scene here. This is a very basic scene with some primitives, some asset store things, very small scene. Anyway, occlusion culling is essentially the act of hiding things that your camera is not directly observing. So your camera is never going to be, well, for the most part, it shouldn't ever be, looking at your entire scene within a game engine. For the most part, you're just going to be looking in one direction, you're just going to be seeing certain things at any given point in time, and to improve on performance, uh, anything that is not being directly observed by your camera, whether it is a camera for a third-person character controller, a first-person character controller, a capsule controller, or just a camera that you have in a scene independently, anything that is not being directly observed by a camera should be hidden and pop out of existence, essentially, for, to understand that in layman's terms. That's not happening right now. Obviously, we're not taking any sort of hit on our performance here because this is a very, very simple scene with very, very few assets. But let's imagine for a moment that we had a much bigger, more complex scene, and anytime we played the scene, things slowed down a little bit. So how can we improve on the performance? We do it by applying occlusion culling to the scene. Now, how do we actually go about doing that? Thankfully, it is a very, very straightforward and simple process. I'm going to unselect my camera. I'm going to go to objects, because objects comprises of all of the things in my scene. We can actually just not hide this and see that all of the things in the scene are under the objects empty objects empty game object here. So let's go ahead. Now that we have objects selected, we're going to go to the inspector. We're not going to do anything with the components. Instead, we're going to go up here to this little arrow right here. We're going to click on it, and we're going to see two options here that we can check off. Currently, we have nothing checked off, but we want to go here to occluder static and occludee static, and we want to check both those things off. Because I'm selecting this for a parent empty game object, it is going to ask me if I want to enable this specific occluder flag to all of the children, which, yes, that is the reason why I'm doing this. So yes, change children. And this occludee static, I'm also going to select, and yes, change children for that too. And now for every single one of these child objects, like the flower or the hill or anything like that, if I go to the arrow here in the inspector, I can see occluder and occludee is checked off. I go here, occluder, occludee checked off. Here, occluder, occludee checked off. Perfect. Okay, so what does that do? What are occluders and occludees? So an occluder is essentially an object that can hide other objects from view, depending on the positioning of our camera. And an occludee is an object that can be hidden from view because it's being occluded by some other object that is in front of it, but can't in itself hide things, can't hide other objects from view. That is a very, very formal and roundabout way of saying that sometimes you check things off because you want them to be able to hide objects that are behind them, and sometimes you have objects that are never going to be behind anything else and just need to be hidden on their own. When it comes to your work with occlusion culling, always just check both of them off. Occluder and occludee, just check both of them off all the time. There is no reason to not be checking both of them off all of the time. The formal definitions of occluder and occludee will be available to you on the course website, but in reality, you just want to check both of them off. There's no reason not to check both of them off in most cases. There are a few objects here and there where you absolutely do not want to check off occluder and occludee. As an example, the character controller and the camera are examples of objects that you probably never want to make occluders or occludees, because there is very, very little reason to ever hide your player from any scene that you're making. Generally, when you're making a game, you don't want to hide your player character. Anyway, we checked off all this stuff, the occluders, the occludees. Nothing has happened yet. All we've done is just said that if we were to bake in occlusion culling, then these particular objects with the occluders and the occludees would be affected by it. So what do we do next? Well, now we can actually, you know what? Before we discuss the next step of occlusion culling, I want to go up here to a layout real quick. And I want to click 2x3. So real quick, I want to discuss something that you may see when you watch Unity tutorial videos online, and that's the fact that their layout for the game engine may be radically different to what you usually work with, which is this basic layout here, this basic 4-panel layout here. A lot of Unity tutorial videos will work in different kind of panel layouts, sort of like this one that we have here, this 2x3 setup here. As beginners, I don't recommend you jump into these kinds of different layouts unless you're comfortable with it. I mean, you can if you want to. There's nothing stopping you from picking these particular layouts. As beginners, the basic default layout works well for you and to get used to everything. But once you start doing more niche work like occlusion culling, then you're probably going to reap the advantages of getting used to other kinds of Unity game engine layouts like this. And you can either select from pre-selected layouts, or you can actually start individually moving your panels here, like the inspector panel. Let's say for some reason I wanted the inspector panel to be here with the hierarchy, right? Now I have the hierarchy here in one tab and the inspector in another, and I have the scene panel taking up more real estate if I want to. Maybe I want it to work like that. Maybe I don't. Maybe I want it to put the console thing up here as well, and just have the project be completely on its own and switch from hierarchy to inspector to console. I can do that if I want to. I can also add in new panels, which we're going to do in a second. First, let me just go back to basic default here. You have the power to switch around the layout of the panels in the Unity game engine and to add in more panels. So for our purposes, I'm actually going to go to 2x3. I'm going to make sure I can see my hierarchy. I mean, it's not that important that I see the hierarchy at this point. And now let's actually move on with the occlusion culling. So let's go to Window. Let's go down to Rendering. And instead of lighting that we selected back in week 5, we're going to select Occlusion Culling. And we have a new tab here in our inspector panel called Occlusion. So at this point, everything that we have marked as occluders and occludees, again, we've marked all this stuff as occluders and occludees, all the stuff that we want to make occlusion culling. We just jump over to the bake under occlusion, and we have some default parameters here for smallest occluder, smallest hole, backface threshold. I'm not going to worry about changing the numbers here. I'm just going to go ahead and say bake. Should be very quick. It took like less than a second. You can see our occlusion data bake size here as 82.9 kilobytes. So it's a very, very small bake. It doesn't take that much space. But then again, this is a very, very small scene. Let's see what changed here, shall we? Now that we have actually baked in the occlusion, from what we can see, nothing has really changed. Everything is still just in existence. That's potentially not good, but in reality, in order to actually see, the effects of what you've just done, you can go here to occlusion culling and go to visualize, and you can change that to edit, and we can see these big blue cubes all over the place. These big blue cubes represent the area in which the occlusion culling has taken effect. And if we want to actually visualize it ourselves, we can actually go from edit to visualize. Again, we're not actually seeing anything, but that's because we have to select the camera of our scene. Once we select the camera, we can see that, oh yes, things have in fact changed. Things have started to disappear, things that are not being directly observed by our camera. So let's go ahead and just take our camera here. Let's start rotating it around independently so we can see the changes. Anything that is not being directly observed by the camera is being hidden away. By the way, you will notice that this red wall here, there is supposed to be a small cube floating behind it. You can in fact still see the shadow of that small cube there. But because it is behind that wall, it is not. It's because it's behind this wall, and this wall is an occluder. It is hiding objects behind it to save on performance. So we can rotate around, we can rotate up. Round disappears too. We can rotate down. We can move the camera. Now that there's no occluder blocking the way, that cube comes back into existence here. Wonderful. By the way, this whole time there has been another cube underneath the scene just to show off the power of occlusion. It disappears as soon as we head back up because this ground here is also in fact an occluder of its own. So this occludee object here, this little cube, is also being hidden away when not when it's being behind this this floor. And we can see that the sphere is also an occluder. Everything here is an occluder and an occludee. You want to make sure, as you set everything up, that you just make everything occluders and occludees. It's just going to be much easier for you. All right, let's set this back to my default positioning here. There we go. I believe that is the default positioning for the camera. Let's actually play the scene. My game view is in the bottom left. As you can see, nothing has changed in the game scene itself. The game scene plays exactly as it did before I did the occlusion culling, which is the point. Occlusion culling is an invisible performance boost for your game that you should take the time to implement into your work. All right, let's exit out of that. And let's discuss a little bit more about these settings here. So first of all, if you did the occlusion culling and you weren't happy with the results, then you can just go to clear and just make sure you check off baked data and cache data. They should already be checked by default, and just press clear. And there you go. No occlusion data has been baked. We are back to the default setup that we were at before the occlusion culling took effect the first time. So let's actually go over these three basic parameters here. So we have smallest occluder, which is the small. Which, by the way, you can just hover your mouse over these three parameters, and they give you they give you a description of what each thing does. So the smallest occluder is the minimum size that any object has to be to block the visibility of objects behind it. So this is currently set to 5. 5 is working off of Unity's meter measurement system. So it's objects that are 5 meters or higher, 5 meters or bigger, are going to be able to block the visibility of objects that are behind it. You want to make this number smaller if you're working with much smaller objects in your scene, or if you're making VR games. If you're making VR games, you have to hold up objects like directly in front of your headset, in front of your face, in front of your camera and stuff, and that is going to mean that those objects are going to be very small, but they should still be responsible for blocking things behind it. It's a good idea to make this small for your own personal setups at home with your with your own laptops and PCs and such. Keep these three values at their default. There's no reason why the default values shouldn't work for the majority of the scenes that you yourself create as beginners. But, getting deeper into it, if you have more powerful hardware, then, setting this smaller is a good idea. Smallest whole is the idea that a lot of assets that you create or import into Unity are going to have naturally little holes in them. One of the examples is like this ladder or like this little fencing. These aren't, very little holes. These are, very big gaps in between pieces of the 3D model. But you take the point, I hope, that there's going to be lots of objects out there that naturally just have little holes in them, and this determines the size of a hole that a player can still see through. And if a hole is smaller than 0.25 in this case, then you're just not going to be able to see through it. It's going to be solid in order to save on performance. There is, again, for more powerful hardware, there's no reason to make this to keep it at 0.25. You can make it smaller if you want to. The recommended size I usually see online is between 0.05 and 0.5. 0.25 is already within that margin, but I'm going to make it smaller at 0.1. That's usually a good idea. Backface threshold is size optimization, hiding things that are under or inside other objects. So, if you had an asset or a render or something where, we take the sphere, for example, and you go inside the sphere. Let's say that there was like, some geometry inside of this sphere. Backface threshold at 100 doesn't remove any of that geometry that is inside of other geometry at all. Whereas if you push this down all the way to a very aggressive 5, then any sort of geometry that is inside of other geometry just disappears. Again, as a method to save on performance. So let's go ahead and let's actually bake this. I'm going to take these very, very aggressive settings here. I'm going to bake them. This is going to take a little bit while longer. You can see down here the computing occlusion. It's going to be a much slower computation compared to the first time where it was like literally in a second. You can see that smallest occluder determines the number of blue cubes that we have. So originally we had, about a dozen or 2 dozen of these giant blue cubes covering the scene. Now we're going to have potentially thousands of these little blue cubes because we are doing a much more sophisticated occlusion bake of our scene here. Again, the default values for smallest occluder, smallest hole, and backface threshold should be fine for your work as students. But if you wanted to push this further beyond your time at this college, then push it and create scenes where you push the where you push and make the occlusion more sophisticated like this. You can see thousands, probably maybe potentially even millions of these blue cubes that are being generated now. It's a very, very slow computation process. I'm actually going to jump ahead to when this computation process is done. So I will see you in a second. All right, and we're back. So I went ahead and actually redid the baking for the occlusions. You'll notice that the occlusions, there's a lot more blue squares now. Thousands of blue squares as opposed to the very few big ones before, but they're not covering the entire scene. That is because I tried to do the, super aggressive, high quality occlusion to the entire scene, and it was taking forever. It would have gotten done, but it would have taken like an hour, and that's not time that I want to put into such a simple scene. So instead, I just occluded a few basic things: the sphere, the ground, and these three plants here, these three little bushes here. I went ahead and occluded that stuff. And the main reason why I wanted to occlude a few things in the most aggressive settings is to draw attention once again to the occlusion data size, the bake size for the occlusion culling. So when we occluded the whole scene with the default parameters, which were the 5.25 and the 100, we had kilobytes of data that were allocated for the occlusion culling, whereas for just a few objects, the super finely detailed 0.1, 0.1, and 5 culling, the best and most powerful kind of occlusion culling, even for just a few objects, we're already at 6.6 megabytes. Probably would have been bigger with the entire scene, and for more complex, sophisticated scenes would have been even bigger. So what I'm getting at is the default parameters for your machines are going to be just fine. Anytime occlusion culling is asked for in your work from this point onward, usually the default parameters are going to be okay. You're going to need, really, really powerful hardware or very, very sophisticated scenes to justify using, the 0.1, the 0.1, and the 5. Eventually, you will have to do things in such fine detail, but for your purposes, the default parameters are going to be just fine for you. When it comes to the actual how they work, let's see, we can rotate our camera. Let's actually go from edit to visualize. There we go. Works about the same, You're not going to see that much difference in terms of performance while you're actually playing and such, which is the whole point of occlusion culling. You don't want to see that you don't want to see the work that's being done here. Anyway, point is, with the baking, the default parameters are going to be fine. The finer parameters are going to be good for more sophisticated scenes and more sophisticated hardware, but be aware that they will increase the data bake size. But even then, if your hardware can handle it, feel free to incorporate it. So I'm going to clear this bake data here. All right, so here we go. 2 things I wanted to show. First off, I wanted to discuss other shading modes for your scene view. We're back to the default We're back to the default layout for Unity, by the way. If you go up here to the draw mode, we can change the appearance of our scene to different kinds of shadings, which can be useful when setting up your occlusion culling, or just, to get a lay of the land for your scenes. We have wireframe, we have shaded wireframe. Overdraw is quite useful, I find, especially when you want to find things that are hidden behind other objects, like that cube, like that ladder, like that runestone over there. Let's see, mip maps. Yeah, plenty of kinds of draw modes here that you can play with and take a look at your scene through. Just for a different perspective on things and to consider things that you may not have considered before. Last thing I want to do is open up a different scene. So let's go ahead and go to my test terrain from previous weeks. I'm not going to save that. And I'm going to apply occlusion culling to this, just to show you, once more, the power of occlusion culling on a slightly more sophisticated scene. I'm going to use the default parameters. I am going to go ahead and just double check that in my inspector, that my terrain has occluders and occludees. It does. I believe with terrains, occluders and occludee statics is checked off automatically, so that's a good thing. You don't even need to worry about this step when you're doing occlusion culling. So let's go ahead and go to occlusion. I'm just going to bake my terrain right now with the basic default parameters. Bake. Give that a second. Very small file size, against 65.1 kilobytes. Big cubes instead of those, thousands of small ones. Let's go to visualize, and we can see that it is working as intended. Let's actually go ahead and go to a 2x3 view. And let's go back to, let's actually get occlusion culling back. So window, rendering, occlusion culling, visualization, perfect. Okay, let's play the scene. Walking around, exploring. From a game perspective, nothing has changed, but from, as you can see from the scene panel, the occlusion culling is doing its work exactly as intended. All right, so this has been just a video on occlusion culling. I hope this helps you get introduced to the concept of it. Feel free to play around with it yourself. Be aware that because occlusion culling bakes in the information to your scenes, that this is one of the last things you should do for any scene that you work on. Occlusion culling should be a last step and not a first step for whatever you work on. All right? With that, I have nothing more to say on the introduction to occlusion culling. So thank you very much for watching. See you all next time. Bye-bye.